Hello and welcome back to my channel. In this part 2 of the series, we're going to pre-process our data. Make sure that you have watched the first part of this series wherein we load and save the data as well as visualize the data. Okay, let's get started. First, we're going to use the stratified shuffle split class and make an instance of it, call it SS. And the parameters are this: it has one split and the test size is 20,000. As previously in the previous video, we know that the number of data points or rows is 70,000. So we're just going to get about 20,000 as another group, okay, and the 50,000 will be used to train the data. So the test size on this one is 20,000, and the random state I put it at 23. The random state is necessary in order for us if there's a in order for us to run again and have the same result if we're going to rerun again the program. Okay? So here we're going to make a for loop, and based on the train we going to have a train index and a group index, or two indices in SS.split if we're going to put in the x data and the y data. So for train index and group index in SS.split x and y data, okay, we're going to separate the x train and the x group based on the indices gathered. So x and the train index is the first index, which is composed of 50,000 points, and these 20,000 points will be in the group index or the second index in SS.split. So we split the data into X train and X group for the X data, and the Y train and the Y group for the Y data or the label data. Okay, so the Y train index, which is composed of 50,000 labels, will be in the Y train, and the another group, Y group index, which is composed of the Y group labels, 20,000 of them, is on the Y group. Okay. Afterwards, we again make an instance of a stratified shuffle split class, and we call it again with the same name. You can call it any name you want. I call it SS, and then we're going to split again these 20,000 data points. We split it again in half, so the test site is only 10,000, and I put it again the random state at 23. So for test index and validation index, so this group data set, X group and Y group, will be separated into test group and validation group because we already have the train group. So the test index and validation index, or the two indices in X group and the Y group, will be divided into X test and validation test. Test group and validation group. So as you can see, the X test corresponds to S group with a test index, which is 10,000 points, and the validation group X valid, which is composed of the X group and the valid index. Same is true with the Y dataset, which is the Y test and the Y valid, which are separated from the Y group with the test index and the validation index. Make no mistake about this, so that the test index pertains to the first index. You can call this any name you want, okay, and you can call this also with any name you want, index 1 or index 2, the same. This will be divided into two. Okay, I hope that is clear. Next one, after we divide these groups, we need to normalize first the data. So in order to normalize this, we create an instance of the standard scalar class SC, and the X train, which is composed of 50,000 points, will be transformed into will be standardized. Okay, so we issue this command sc, and fit transform, or the function inside the sc object fit transform X train, and so the X train will be normalized now. And the next one, the X validation dataset, will be transformed using only the command sc.transform, because the sc object already contains the fit data. Fit data will have the mean value of the X train as well as the standard deviation of the X train. We will use the mean and the standard deviation, and we're going to compute the we're going to compute the standard scale for the validation dataset. Same is true with the test dataset. So transform it using the mean and the standard deviation obtained from this data from the X train and transform the X test. Okay. After we normalize all the X data, we make the tensor out of them. In order to do that, we just issue the command torch the tensor with the X train and make sure that the output is of type float. So we just issue this on the same tree. As you can see, there's no need. The data set is already have the 700. How much it is? Already have 784 columns. So it's already been flattened. Okay, the data is already been flattened. Afterwards, we need to change also the type of the training or the label dataset. First of all, we need to change this into a type of integer. As you saw earlier here, if we recall, they are all characters or strings. Okay, strings, character string, character because this is just one string. Okay, so they are all characters. We convert these characters into or string into type of integer. So as we convert them into integer prior to making them a tensor, we cannot make we cannot make these characters directly into tensor. So we just need to make define them as a different type of data prior to making them a tensor. So change the string to type integer and change it to tensor. So we change this tree and we have this y train, y valid, and y test as type integer. Okay, so we run this cell. We wait for this command to finish. Okay, and afterward, if we want to view, let's view one of the data. Let's say y test. Okay, let's view it, y test. As you can see, they are now tensor in a type integers, double integers. I think this is double integers. Okay, so they are now type integers. Okay, in order to continue, we check now the validation dataset. For example, the validation of type of the row 2. It has a shape of 784. Okay, for the whole validation data set, we'll just issue the command x valid that shape. Okay, so as you can see, as I've said before, it is now at 10,000 rows. Okay, 10,000 data set and 784 columns of or the number of pixels. Okay, this is just the same. X train that shape, the same. Next is we're going to have it trained per batch. We're going to train the X train on the per batch. So if we have here we have 50,000 data points, we're going to make a batch out of them. So we train first, I think that 100 data points and the next 100 data points and so on and so forth. In order to do that, we make first a child class DDS of a parent class dataset. Okay, so in this child class DDS, we need to initialize it that it will require the input data of X and Y. We need to do this because it requires that this class is of type dataset prior to loading to PyTorch data loader class. Okay, so here is what we're going to do. First, we put it inside the x values and the y values. Okay, this is x train and this is y train labels. Okay, next we define another function inside this DDS child class, which is get item. Okay, and it will require the index and it will return the self.index here and self.y with this index. The function data loader will be the one to put in here the number or the indices, and it will get it inside this x. Next is this one is we're going to return the value of the length of this, or how many rows are there or how many data points are there inside this x. You can also use X or the Y because they have the same length anyways. So in order so for this DDS or the dataset sub child class of this dataset, we need to define these three functions. Okay, so we need to do that. Afterwards, we're going to load this in a per batch basis. So as you can see, I make X train and Y train into load it inside a DDS class. Okay, and put it in my data. So my data is an object of type DDS class which has X train and Y train data on it. Next is we're going to feed this up inside a data loader class. Okay, data loader class, and we put it here as parameters. The data set we are interested in is my data, and the batch size, this is what I'm telling you about. The batch size is 100. You can modify it if you want a faster training into 200 or 1000 or 500 or whatever you want, but in this case I'm just gonna make it 100. So on each bus of 100 it will compute all the necessary gradient, so on and so forth, the loss function, the loss, the forward and the backward propagation in the neural network using the batch size of 100. Okay, so we just need to do that. Okay, that is all for now. See you in the part 3 of this series. Okay, so bye for now. Bye.